Let me now start off with Dr. Seidler, and following him will be Steve Strauss. Dr. Seidler.
Let's see if this is on. Is it? Oh, it. So I think we need to. Testing 1, 2, 3.
Tom, yeah, Tom, you need to
Get
separate.
that mic away. Turn that mic off. Just turn that one off.
I did.
Oh, okay.
It's off.
We have some type of magnetism for each other. Sorry. It's off. Okay. How many here were at the previous talk? Not many, right? Oh, okay. So I'll make believe in my mind that that didn't happen. I'm still hearing a little echo. Okay, testing 1, 2, 3. Can you hear me now? Okay, no echo, that's good. Hey, I want to start this by making sure that everyone here knows a little bit about me as Tom started. I am a scientist. I am retired. I love science. People ask me about my work and the like. I said, that's not work, that's not job, that's my hobby. So there have been some comments from the public that are confused, that think I'm anti-science or whatever. And I just have to tell you that's really far from the truth. Regarding the technology and the methods that Steve and I are going to talk about this afternoon, I too have used them in my laboratory over the years. I've used the methods, and I actually, through my technicians and students, we developed some new applications of the methodologies. So, hey, you know, just because I'm retired and I got the old white hair thing going, I am a scientist and I practice very hard for about 35 years. Okay, enough of that. I'm going to tell you what I'm going to tell you. Try to set the story straight. After about 17 years of commercialization and at least 30 years since Nobel recognition of the scientific work that was started here in the West Coast in California, I don't see any miracle crops out in the field yet. And they may be coming. I know they are in the pipeline, but we don't have time for me to try to share and explain to you how difficult it is to get from the laboratory to the greenhouse, to the field, to commercialization. And I don't mean that has anything to do with the regulatory oversight, just the science piece. So where I'm coming from today, I will tell you, I just don't see any differences between conventional farming practices and those practiced by farmers who are growing genetically engineered crops. I don't see any differences in pollution abatements, any unique benefits regarding climate change, drought tolerance. But what I do see, and I think Steve and I agree on this, the management of this technology, as beautiful as it may be with medical applications, it's a mess. I'm not anti-medicine. I'm not anti-pharmacy, and I forgot to tell you that just yesterday I finished teaching a class at the O.S.U Lifelong Learning Institute at Southern Oregon University, and we talked, the whole class was about techniques in genetic engineering. So am I the world's expert? Heck no. But do I think I know what I'm talking about? You better believe it. First thing I want to start off with is about the patent. Are farmers being sued? Are farmers paying up money because they've been experienced, they have experienced innocent infringement? You bet your life they have. To the tune of over $15 million. And that is peanuts to Monsanto, but not so to farmers. And the reason why I even bring that up, in my opinion, that has been done to teach a lesson. Farmers are working through contracts. They are working with seeds they do not own. They are working with material that if their pollen drifts over in another farm, the people on the receiving end are in trouble if they go to sell that material. So cross-pollination may happen, it does happen, and it goes both ways, genetically engineered, ungenetically engineered. But only in one direction is it protected by patent law. Furthermore, in a case going back 10 years ago now, the right to prevent anyone from studying the seeds, the crops associated with that patent is forbidden unless you have a signed agreement with the seed company who owns the patent. And in a way, you know, that shouldn't be too surprising. That's part of patent protection. I develop something, I'm selling something, I don't want you to ruin it for me by making a mistake in the laboratory if that should happen. So some university professors thought they needed to do some research at Duke University, and Monsanto stepped up and said, no, you can't do that. And they won the lawsuit in federal court. That's one of the reasons why I am going to say, and Steve will differ from me, that the amount of information, technical information, health information, ecological information is rather limited. What mainstream scientists would want to take a chance? Why? There are plenty of other interesting things to do in your research. And I also want to point out there are no such things in patent protection as, oh, I'm innocent, I didn't know it came over. Not my fault, it's my farmer's fault. He's the genetically engineered farmer guy. I don't have anything to do with it, it was Mother Nature, sorry, no excuse. And what it means in a practical context, your customer may not be able to buy your product. It's not the genetic engineering technique fault, it's the management that tells us that there are people in the world that just don't want to buy these things. Right or wrong, good or bad, it's their culture, it's their habitat, and it's their right to say no. And if you try to sell a crop that's been cross-pollinated, you're in trouble. Could be in trouble, I should say, if it's discovered. If you're going to eat your whole crop yourself and don't sell it, no problem. But if you sell it, you're selling somebody else's seed, somebody else's property that's protected. All right, going on. One of the main driving forces for our American farmers and their technology is you're going to increase your yield. Therefore, you're going to make more money. And by God, you've got to know that I don't have any problems with our farmers making more money. I too was a hobby farmer, very serious hobby farmer, on 80 acres, and damn near lost my shirt. That was not my profession. Boy, it's hard work to be a farmer. So if you have a leg up to make money, go for it. And that's what our farmers have done. And let me share with you, I usually just use one slide in this part of my presentation, but I've had some pushback. So I'm going to try for 4 slides to see if I can convince anyone here of what the yields are like. So I'm going to show you something, first starting out with a table of data from a corn production contest that's held in the state of Ohio every year. I'm going to show you 2 years of data that's available. I'm going to show you that the average yield in this contest over 2 years using 19 varieties of corn was about 220 bushels per acre. Anyone in here know what the average is for corn bushels per acre?
84.
Indiana's 165.
National average is actually 160. So do they know how to grow corn in Ohio? You better believe it. Their average was 220. And they compared non-genetically engineered corn yields with conventional. This is not my number. This is not my data. This is published through the Extension Office at Ohio State University. What did they find? Non-GMO average was 221, and the GMO average was 219. Don't get excited. Just because the non-GMO is a higher number, they're the same. By any mathematician's book, they're the same. let's dig down a little deeper into the individual results. So I said that there are 19 varieties using 16 GMO. Well, 6 varieties of genetically engineered corn yields exceeded that of the non-genetically engineered. These farmers did better off by paying extra, a lot extra for the corn seed, for signing the contract, having their lawyer interpret the 11 to 14 page seed contract, plus the royalty fees. They better get more yield.
Dr. Ray, could you put the mic near your butt, near your button? Bring it down to your button. We're having a hard time here.
Could you help me with that? Thanks, Kevin.
Right there.
Okay. And what happened to those folks that were in the rest of the contest? In 10 cases, the GMO yields were less. A little of the yields were more with certain varieties, other varieties a little less, and it all balances out in the end. Okay, Bob Nielsen of the agronomy department in Purdue University in Indiana has spent his career studying corn, and he's known as Mr. Corn. And he's taken a lot of data from about 150, 160 years, the lifetime of the U.S. Department of Agriculture. Again, not his numbers, numbers compiled by the USDA. And I want to point out in this part of the graph, you see all these red boxes? That shows that since World War II, technology has given our farmers the capabilities to produce more corn, more corn, more corn every year since World War II at the rate of about 2 bushels more per year. That's why this line goes up, and it's 2 bushels, 2 bushels, 2 bushels on average every year. The green section up here at the top is genetically engineered corn. And in the same line with the same slope that started in World War II through the 50s, 60s, 70s, 80s, 90s, 2000, 2010, the line there has the same slope. That means, translation, there's no differential increase in the corn yields per year. Not my data, not my comments, it's the U.S. Department of Agriculture records for the whole country. Another study by a friend of mine, and he and I go back many, many years. Did this just go dead? No. Okay. His name is Jack Heinemann. He happens to be at Christchurch University in New Zealand. And he wanted to see what was going on in the United States versus Europe. And let's go through the slide quickly. The squiggles up and down, up and down, up and down just say that corn yields vary each year due to the weather patterns. The United States is the light line here, up and down, and you see a bold linear line. He's linearized the data to the best fit over that 50, 60-year period. Initially, in the 60s, 70s, and 80s, the dashed line was the corn yield in the U.S., just a little bit better than in Europe, Western Europe. And then kind of cross came together around 1990. And then GMO corn was introduced, and again, the same straight line, the slope does not change, the rate of change is still there. About 2 bushels per year in Western Europe, 2 bushels per year increase in the United States. They're doing just as good as we are, or we're doing just as good as they are if you're from Europe. But there's a little difference here. The corn data from Europe is from non-genetically engineered corn. Their corn is doing just as well as ours. Theirs is not genetically engineered. And finally, and we're all going to laugh at this because Steve just presented data from the same report, another excerpt. And his excerpt is different from mine. I had to laugh, and I'll tell you what's going on here. 2 months ago, the USDA issued a 40-page report all about how we're doing with our genetically engineered crops. And in that report, there is a quote I'll offer you, over the last 15 years of use, GMO seeds have not been shown to definitively increase yield. In fact, the yields of the BT-resistant, Roundup-resistant seeds may be occasionally lower than the yields of conventional varieties. Got that? That's U.S. Department of Agriculture report. It is unusual, in my professional opinion, for the world's advocate, leading institution that promotes American farming, to say that something isn't working as good as we thought. I don't know when they've ever said that, but if you read carefully in that report, you can get as confused as I was. Steve chose a statement that says kind of the opposite. Things are going better. How can that be? And my personal take on this is that damn report was so heavily edited. It's confusing for everyone who reads it. And the bottom line, I defer, look at and think about my previous 3 slides of published, peer-reviewed scientific data, 150 years USDA data. You decide whether my comment from the report or Steve's comment from the report is correct based on the scientific data. I'll tell you that there are a lot of references given in that report. Find the report. Read it. Get as confused as you want. Look at the references in the back. And I can tell you that I'm disappointed in those references. They're what we call non-mainstream information. One of them that I found is a talk, like I'm giving now, where somebody is quoted, "My yields were beyond comparison with my non-genetically engineered crop neighbors." That kind of stuff. There's another report that says our yields in our experimental studies, how was that phrased? Did not show a decline. Did not show a decline in yields. Does that mean they were average? They were good? Oh, they didn't show a decline. Were they higher? I don't know. I couldn't find it. Didn't show a decline. And who do you think that publication was from in the USDA report? A seed producer. And the first 3 initials are MON. Did not show a decline over the yields compared to non-genetically engineered. Come on, folks. Think about the data in the published, reviewed literature. Get over it. The genes that are moved from the soil bacteria into our soy, into our cotton, into our canola, into our corn, don't say, "I'm a yield increasing gene, move me over." No. They don't do that. It's all about how you manage your crop once you plant those seeds. Sometimes that's out of the hands of the farmer, right? Maybe there's some bad weather. Maybe there's a drought. Maybe you have a weed infestation. And your neighbor across the street that has a non-GMO crop doesn't have that weed. He's going to do better than you. And vice versa. It all balances out when you look at a large enough national sampling event, my opinion. A lot of under-information, a lot of cloudy information about toxicology, and I'm not going to stand up here and tell you I have the answers, but I am getting a little bit nervous about now 4 studies that have come out in the last handful of years. So I'm going to bait you to stand by on that, but I want to show you two other slides first. Then I'm going to tell you why I'm a little uneasy. Something might be going on that bothers me. So let's start here. I want to draw your attention to this part of the slide, health risk. It's a universal equation that our regulators use, that toxicologists use around the world. And it says, what is the risk all about? It's the toxicity of the chemical times how much you get exposure to. And this means if you have 5 units of toxicity and 5 units of exposure, the risk is not 5 plus 5, the risk is 25. 5 times 5. And it also says if you have a chemical that is very low in toxicity, you're all right. But you have continual exposure day in and day out, day in and day out. So your exposure part of that equation is up there, it's high. It doesn't take too much toxicity to get a detectable risk. You got that? You know what I'm trying to say here? It's exposure times how hot, how dirty, how bad a chemical is. Let's look at Roundup or glyphosate, the active ingredient. It's everywhere. It's in our air we breathe. It's in the water we drink. It's in the food we consume. It's in our rainwater. So we get a lot of the right side of this equation. We get a lot of exposure. And look at this funny equation that I've got here. The amount in our food means it's greater than in human breast milk, it's greater than in urine, it's greater than in drinking water, and greater than in rainwater. Let's say we excrete it in our urine. The tests have been done. Yes, we do. And do you know the amount we excrete in the United States is 10 times the level that of the Europeans? Why is it 10 times higher here in our country? Do we have more exposure? Yeah. Okay. The concentration in breast milk, human breast milk, is 10 times that excreted in our urine. 10 times higher. What does that mean? Possibly. It means that there is a risk of bioaccumulation of glyphosate in fatty tissue. Analogous to other bad chemicals, I won't mention their name, because I don't want to scare you. But it's happened before. We've learned about this kind of a phenomenon. But let me quickly add, and I cannot overemphasize this, the breast milk sample analyses are probably unreliable. I have to tell you there's only 10 samples taken throughout the United States. 3 of those were positive out of the 10. I'm not going to stake my reputation, for whatever that's worth, on trying to emphasize this is something we need to worry about. There's a lot coming out of breast milk. Oh my God. Not what I'm saying. I am saying we definitely need to follow up. We need a planned scientific analysis on the breast milk glyphosate situation. Okay, what am I uneasy about? There are now 4 scientific studies in the last 3 years or so. The last one a few months ago, from 4 different continents, and the scientists from 4 different continents: North America, South America, Europe, and now Asia. And they all are saying, hey, it looks like we are seeing some evidence for hormonal disruptive processes in our assays in which we're adding glyphosate. 2 of those 4 studies have been discredited. The other 2, not yet discredited. Taken collectively, something might be going on here. Let me show you a little bit about what happens to critters if we take glyphosate out of our food. Let's make believe, okay, we have glyphosate in our food 3 to 10 parts per million. We can extract that in a chemically pure state and use it in the artificial conditions and laboratory assays. We find that it kills little fish. It stops the growth of earthworms. These are, I want to emphasize, not field studies, all done in the laboratory. It causes endocrine disruption, hormonal changes in developing frogs. They produce 1 leg, they produce 3 legs, and they produce females that have sperm, and they produce male frogs that are making eggs. It's called intersex changes. Exposures to the amount of Roundup in our food. Can we extrapolate? Frogs, hey, they're very sensitive to environmental perturbations. That's why scientists use them. They drink through their skin, so any little bit of toxic stuff is going to hit them pretty hard. So to extrapolate from a frog to a human, I don't think there's a mainstream scientist that walks the planet that's going to say, oh yeah, it's going to get to you. That's not what I'm saying. All I'm saying is here's some evidence from scientists in 4 different countries that are trying to say they're picking up on something. They see some changes in multiplication of human breast cancer. They see some changes in hormonal imbalances in frogs. They see deaths in young fish. All of this is artifactual. All of this is mistake, errors. All of this is junk science. Personally, I don't think so. Are we ready to announce to our regulators they've made another mistake? Like with DDT, PCB, thalidomide, hormone replacement therapy, testosterone therapy. This is added to the list? No, we're not there. But I'm beginning to see a flag go up, and I'm a little nervous about that. And I can be criticized for being nervous, but I'm ready. Okay, golden rice syndrome, I call it. What another mess. There are people by the millions, youngsters and pregnant women in the world, that are waiting for this genetically engineered rice to appear on their breakfast table. Because in the part of the world where they live and their diet is short of an essential nutrient for normal development of a human being, and that's vitamin A. We can't live without it. So scientists have been working at least 20 years to figure out how to add vitamin A to rice. And it's called golden rice because of a pigment that our scientists, not Americans, but the scientists, have learned to add through genetic engineering. And it produces a pigment, it's yellow, that's why we call it golden rice. But I have to say a couple of things that are very disturbing. It's taken a long time, and those that are pro-GMO advocates, this is the beginning of a new world, etc., are saying the regulators are holding this up while children are dying out there. Give me a break. It's not just the regulators that are involved, and they should be, and I'll tell you why in a moment. I have to recover from that excitement. Do you think that humanity is sitting on their hands letting this happen while we're waiting for something that may or may not come along, that may or may not work? The pro-GMO folks do not tip their hats to the thousands of volunteers that are out there at this moment in Africa and in Southeast Asia, working through the World Health Organization, providing a separate mechanism for giving these people vitamin A. Volunteers have been doing this successfully since 1982. Nobody's sitting waiting for golden corn that is held up by regulators. No, 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 no. Let's tip our hats to those volunteers that are out there saving lives. You ever hear about something called vitamin A toxicity? Mm-hmm. here's some rice. This is the non-genetically engineered. This is the yellow phase 1, and this is the darker phase 2 rice that is producing still higher amounts of vitamin A. Too much of a good thing is bad. And let me tell you and present and offer these comments, some of the reasons why we're waiting so long for the golden rice to hit the plate of these people involve mistakes made by molecular biologists and using the wrong varieties of culturally acceptable rice, followed by just, it's tough science. This has never been done before. Followed by, geez, what we got in here is not stable, it's not high enough, you gotta eat this much rice, so let's put more gene activity in. That's okay, that's a learning curve. That's how science works and develops. But in my estimation, vitamin A, because it has medical risks if you overdose, should be treated as a pharmaceutical, not as a food additive, because it can kill you. What the heck am I talking about? Excuse the technicalities here, but basically what I want to tell you is that beta-carotene is the golden colored material that is being produced in golden rice, not vitamin A. But through a series of about 3 steps in the human body, when this beta-carotene is consumed, it produces something called retinol, which is the vitamin A. So as you increase the beta-carotene, you get more vitamin A. So if you go really high on the yellow stuff, beta-carotene, there is a risk of overdosing on vitamin A. If you overdose on vitamin A, it knocks out the biological activity of another vitamin called vitamin D. No, vitamin D is in our milk. It's in there for a reason. It prevents osteoporosis. It prevents brittling of the bones. So if you have a pregnant woman who's breastfeeding, if you have a lady who's breastfeeding and she's overdosed on vitamin A, there's a risk of bone brittling activity. On the other end of things, this intermediate compound called retinoic acid is something scientists call a teratogen. That means it causes birth defects. Remember what happened to thalidomide babies? That's the kind of birth defect that'll happen with retinoic acid. So I'm saying be patient with the golden rice development. It's complicated. It's complicated from a genetic engineering perspective. It's complicated from an agricultural perspective and from a medical perspective, from overdosing. Be patient. Maybe it'll come someday. And in the meantime, folks who are working with the World Health Organization say in their rounds in Africa and in Europe, what about growing garden foods? What about leafy vegetables? What about sweet potatoes, radish leaves, curry plant leaves, tomatoes, and amaranth? All, wow, natural, beautiful sources of vitamin A. None of it's genetically engineered. Steve talks about the beautiful engineering that's done with tomatoes. We don't need genetic engineering at all to produce these kinds of tomatoes that are full of beta-carotene and other antioxidants. Those are available, they're called heirloom tomatoes. They're available from a supplier right now today who lives in Jackson County. Why do we need it genetically engineered? Well, maybe somebody needs a patent. Here's what happens through that Helen Keller International Institute. Their volunteers last year reached 50 million children. Hats off to those volunteers. 50 million children who received their vitamin A through 2 drops in a pill, and that's only given twice a year. Not every day, 2 times a year. 50 cents a dose. I'm running out of time. 50 cents a dose. Okay, moving on. We've got to talk about cross-pollination before I'm done. It's a natural process. It goes in both directions. That is to say, if this is a genetically engineered corn, for example, and this is not, the pollen drifts both directions. Of course it does. What's all the fuss? Well, there are people, societies, cultures in the world that say if this happens from left to right, genetically engineered crop to none, it's not a natural process to them. It is contaminated and we just don't want it. We don't want that. Sorry. So if we have a farmer who's in this business of trying to grow some kind of a seed crop and it gets cross-pollinated, it can be detected at least down to 1 in 1,000 seeds or even finer than that. It can be detected. Pollen coming from the non-GE crop to the GE crop, you can't detect it. You can't measure it. Nobody cares if that's happened. People who eat the genetically engineered seeds or wherever they go don't mind if there's 1 in 1,000 cross-pollination events. It's not costing that producer any money. But if it goes the other way, its own patented material. The genes that are in the pollen are owned by the seed company, not by the farmer. And the farmer is fine, as I said earlier. No problem. If you want to eat all your crop, go ahead. Oh, you want to sell it? That's where I'm going to get you if I'm a Monsanto attorney. If I can detect it, and if I suspect for some reason I have the right to test your crop to see if you have DNA, if you have genes there, that belongs to me, not to you. If you're going to sell it, make a profit, hey, that's where I want to be. That's my material. That's part of this ugliness of this management problem that we're all facing. It's ugly. Sure, 10,000 years that's been going on. We've been genetically engineering seeds 17 years. It's a new problem. Cross-pollination. What do you think might happen if it goes on with golden rice, which is a pharmaceutical product? I told you what overdoses could be. What do you think has happened to heritage corn varieties in our neighbor to the south? Last week we heard that corn to them, I can't even describe what it means to their culture. I don't know of an equivalent thing in the United States except maybe American Frankfurters. Hot dogs? I don't know. But to the Mexican, the corn is part of their heritage, their life, their country. And they have this beautiful phrase, sin maíz no hay país. Without our corn, there's no country. That's how deeply they feel. And they had Monsanto corn cross-pollinate with some of their heritage corn. Very disturbing. So disturbing that, activists, let's call them what they are, political activists in their country, along with their scientists who've come to UC Berkeley to study the issue, have filed a class action suit, the third one in the history of the country of Mexico. And they've stopped any further importation of corn from American farmers. Okay, I see you. Steve talked a half an hour over. Let me quickly finish. Our colleague at Oregon State University, Carol Mallory Smith, said we can't contain genes because that's not how biology works. Get over it. It's a natural phenomenon. And even if it's not pollen, it can be seeds that are 1 time, 2 times, 3 times, 4 times removed from the control of the farmer, like has happened in Canada with flax, like has happened recently in the United States trying to get Syngenta corn into China. Didn't work. And I'm not even need to talk to you about this, but it's not just impacting wheat farmers in eastern Oregon. It's impacted a Jackson County farmer to the tune of at least $50,000 who lost his wheat crop, while the big boys were trying to figure out what to do about this little plant contamination in eastern Oregon. And it didn't take 2 months, Steve, it took 4 to 5 months to work out. This is how I envision our agriculture. Scientists from around the world wrote a report, said this can't continue. It's not sustainable. You can't continue to do this and save the environment and make a profit. What are we going to do? And here answers a question to a last slide, I promise. Folks that grow grapes for wine production in Oregon, California, Jackson County has said, hey, you know, if this thing passes, I'm not going to be able to look forward to growing genetically engineered grapes. I understand. I relate to that. Is it a valid concern, though? If you had a choice, a Pinot Noir and a Pinot Noir, one was made from genetically engineered grapes, one not. Which one would you choose? Which one would you choose? First risk. And why not use genetic engineering techniques to say, I wonder if I can detect some mold-resistant genes in wild, natural populations of grapes. There's a resistant gene, and it's going to kill my fungus, and all I got to do is genetically engineer it into my grape, and then I don't have to use my chemicals, right? But what if I told this person that scientists in the U.S. Department of Agriculture and at Cornell University in an international conference that just took place said, we don't need to do it by genetic engineering. We can do it by conventional crossbreeding. That's been practiced for hundreds of years. And that's what those scientists, government scientists, Cornell University scientists are up to doing. What's wrong with that? Okay, I think on that I better stop before I get thrown out. Thanks.